Hello, hello, we're in southern Tenerife right now, and here we have an alignment of cinder cones that's part of the southern rift arm of Tenerife. And here we have a whole series of cinder cones that are well lined up like beads on a string. And if we move a little bit here to the right, we have one of the finest ones, one of my favorite ones. This is Montaña Los Erales. And Los Erales is marked by a little landslide that excavated the interior parts of the cone, and you see this brownish core. But let's quickly look in the other direction first. Here's a few more cones going all the way to the coast, and the one at the coast is Montaña Amarilla. Amarilla is purely hydromagmatic from interaction with the seawater, while the others are dominantly strombolian. And here we have Los Erales again. Los Erales is a bit of an exception because it actually has this interior brownish core which hints at hydromagmatism. There's a lot of palagonite in there, and you need you need water to make palagonite. There's also a lot of bump sacks and fine-grained deposits in there. Maybe I can go a little bit closer here. And this was a hydromagmatic phase that initiated the growth of Los Erales. Higher up we get into a mixed facies and eventually into a rather black to dark reddish oxidized strombolian phase. So this cone started its life as a hydromagmatic eruption, as a hydromagmatic cone, and then gradually it migrated into a more strombolian type of eruption. So it's a progressive eruption style that we're seeing here. And indeed, in the transitional facies, my student Hilary Clark, she found diatoms, so there's good indication that water was in fact involved in the lower parts. So we see this in the textures, we see this in the rock record, and we see this in the minerals, but also there's fossils in there. Intriguingly, here we have a little bit of an excavation, and here is a rock rose. It's a filled lava channel, so there was lava activity also associated with Los Erales, and this is very similar to what we see today in La Palma, 2021 eruption. We have a cinder cone activity, strombolian eruption, but also lavas being emitted from the cone. Now, one of the key features, of course, is how did the water get into this eruptive deposit, or how did the magma interact with the water? And I guess we have to think a little bit about the situation in which Erales is located, and you see it here. Erales is actually located in a little barranco, in a little valley, so there could have been seasonal water in the valley that the magma could have hit. The other option is that there could have been groundwater, shallow level groundwater that could have played a role. And indeed, the map here marks a spring, and the spring is dry these days, but back in those days it might have been an indication, or it is an indication, that back in those days there could have been groundwater present, and this could have well been the reason why the magma coming up in this particular place was interacting with water, with the hydrosphere, producing strombolian eruptions only after initially being hydromagmatic. From a hazard point of view, this is very interesting because it means that what we generally consider as a low risk, i.e. the cinder cone situation, could actually become quite unpleasant if by accident groundwater gets involved, and this is an important realization. Many of the hazard maps here, they look at these potential eruptions as strombolian only, while of course the evidence here is very clear. There could be also interaction with the hydrosphere, and therefore phreatomagmatic explosions are a reality to be considered. So thank you, and last look at Erales, and let's see whether I can zoom out a little bit. Here we go. And well, thank you for your attention, and I hope you enjoyed that. All the very best, and I hope to speak to you soon.